Hello, welcome to my channel. Let's look at today's daily challenge problem. 174 Dungeon Game. It is marked as hard, but it actually is a easy problem in the hard category. So the question is quite long, and let's just go straight to the example. Uh, so uh, the question is that there is a grid with and with the each cell in the grid has a value, which means the increase or decrease of the energy. So the negative value means the decrease of the energy, but the positive value means the increase of the energy. So so a knight will go from the top left corner to the bottom right corner to rescue a princess. So it can only go right or go down. So and in each cell, it will either reduce energy or increase energy, depending on if it's a negative or positive. Or if it's a zero, it can also the energy will not change. So in any cell in the route, the energy cannot be less than or equal to zero. Otherwise, he will die. So the question asks the minimum initial energy he need so that he can reach and rescue princess. So the first example, this value is 7, and it can go this route from firstly go right until cell with 3 and then go down, then until the last cell. So the second example is there is only one cell in the grid, and the value is 0. So which means uh, the the output will be 1 because minimally he needs like 1 energy so that he will not die at the cell. So the constraint is mn is between 1 and 200. So and the dungeon ij is between negative 1000 and positive 1000. So this question, it's because it's asking the minimum value so that we can do something like this. Generally, this type of question can be done using the dynamic programming. So we need to firstly define the DP array. So we can define it as a minimum dpij as minimum energy required at the point ij, so that knight can reach point m-1 and -1. So the calculation direction. So this question, it's likely it's easier we go backwards. So from the lower right corner to the upper left corner. I mean, this is the calculate order. So so firstly, let's look at the last cell. When the cell is when the ij is I is m-1, j is n-1. So what is the required energy there? So dpij, or we can call it dpij m minus 1 and minus 1. So because of this, we need to have it the value, the energy at this cell larger than or equal to 1. So we need to have this equation larger than or equal to 1. Actually, it's plus. So if it's negative, then it's reduced. But if it's positive, then it's increase. Yeah, so then we actually can we can get actually here it's maybe not accurate. So the energy at m minus 1 plus so actually we can move this part to the right of equation, and so we can get the energy need to larger than or equal to 1 minus tangent m minus 1 and minus 1. Then we actually can get the dp value at this point, which is tangent m minus 1 and minus 1. So this can be solved as the base case for the to calculate the other points in the dp array. Then we can now have a look at the other points in the dp array. So we need to have the energy needed to have at those points need to have two conditions. So firstly is because it's possible we go to the right or go down. So we actually can compare dpi plus 1 j and dp ij plus 1. We can compare those two energy, and then we select the smaller one. So then we need to have our energy at ij plus tangent ij, and and also we need to larger than or equal to the minimum of this of the right side or the down cell. So the second condition is we cannot have this value smaller than 1. So we need also to have it larger than or equal to 1. So combining this two conditions, so we need to have this to the max minus tangent ij. So which means that the dp ij here is will be this value. So this is the transition function. So in the end, we just need to output the dp00. So now also the time complexity is it will be O(m) times n. Time and space both are O(m) m times n. So this is the thought process. Let's go to code it. So we can dungeon n is dungeon 0 dot length. Then now we define this dp. dpmn. So yeah, then as I said, we need to go from the go backwards. So we iterate this I and j backwards. So firstly, let's if I consider the situation when I is m minus I and j is n minus 1. And then this one is as we said, this it will be equal to we can actually call it also I minus ij. So I because I is dungeon ij. Then for the now we need to we don't need to continue, so we don't need to continue the calculation for this special case. Now let's do the calculation for the transition function. So we can define one value called next. So we define this as a very large value, so that because we need to get the minimum, then we can, if I is smaller than m minus 1, means we can do a next minimum with the dpi plus 1 j. So this if condition is avoid the outer boundary problem. And similarly for j, we can define this next I j plus 1. Okay, now we can copy this to here. So this part we already calculate, which is the current value of next. So the dpij actually is this. Then we just return dp00. Yeah, so this is the entire code, I think. Let's check if it's working. Oh, okay. Oh yeah, it should be math dot max. Okay, so it's correct for both the example, and let's run the. Okay, there is one. This is wrong. Output. Oh, okay. So dp00. minus expected 1. So once it's there's only one value, it's minimum initial health. So this, it means this value also need to be at least this energy minus 19. The input is 1. So does it mean the energy has to be at least 1 in the initial? Let's see how many cases has it passed. 41 out of 45. So I think when the here we also need to have a max 1 minus dungeon. So this value cannot be smaller than 1. Let's try this again. Yeah, so we have missed this condition in the one I is m minus 1, j and j is n minus 1. So it cannot be negative value. Again, output. Negative 1. Expected is 1. Okay, maybe it shouldn't be that. It should be 1 next minus dungeon. So this equation is a little wrong. Yeah, let's check. Okay. Okay. Sorry about the problem. Yeah, and yeah, so that's finished today's daily challenge. Thank you. So if you like the video, please subscribe or click like button. Thank you for watching. See you next time.